the record. So all of these sessions are recorded, and if you like, you'll get a copy of it so that you can review it if you want.
Yeah, that would be great, I think.
Okay. Do you know how Ryan found me? He said he found me on the internet.
On Google, on the third page back, he said, and he was like, I thought I would just give it a shot and try to just call him.
So what did he Google? Do you remember what his search was by chance?
Algebra tutoring.
Algebra tutoring, and I came up on the third page in California, huh?
Yeah, and he said that it was like the least, I don't know, he felt that it was the best, like, one-on-one. So that's why he was...
Good. I've just recently introduced that website, and he's actually the first person from outside Colorado that has contacted me. So that's why I was curious as to how he found me. But
oh, wow.
Well, third page isn't bad, I guess. First page would be better, but
right. But so let me explain really quick my situation.
Okay.
I have been going to school for a long time, blah, 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 and my school closed down. I had 8 days left before I was going to graduate for dental. So I enrolled in the community college, and then 5 days after the refund period ended, my instructor called and said, hey, I have a job, or I have another school for you to go to. So I'm in 2 schools right now, and this math has really been confusing me. Like last night I worked on one problem. Yesterday I worked on one problem all day long. So it's actually not out of a book. It's online.
Is this the document that we're going to look at today? Ryan sent this to me last night.
Yeah, that's one of them. So the scattergram I think is number 9.
Okay.
Is that right? No, let me see. Let me find it. That's one document, but there's also...
Let's talk about number 9, because I have that plotted already. In other words, I'm all ready to go to explain that to you.
Okay, hold on a second. Let me see which one it is. I think I don't have it filled out on here. I have it on a different thing. But we can talk about that.
Yeah, let's talk about 9.
Okay.
Notice that it says let M be the standard mileage rate in cents per mile at T years since 1990.
Yep.
Okay, well what they give us is a table that only has data from 1998 through 2003. So our x-axis, which is going to be time, is going to go 8, 9, 10, 11, 12, 13. Because 1998 is 8 years after 1990.
Right.
Okay? And then the y values, or the m values in this case, would be the 31.4 through 37.5. Now, there is a very nice website that you might want to check out online called Wolfram Alpha. Can you see it here?
Uh-huh.
Okay. It has a method of entering table information that's just 2 variables, and I've entered that. You can see I got 8, 9, 10, 11, 12, 13 where the x coordinate is, and then I've got the mileage values next to those numbers, and I've asked it to do a linear fit, which is a linear regression. Now, the scatter plot would be the red dots without the line.
Right.
You'll notice that at year 8, it was 31.6, at year 9, 32, whatever. And it has drawn in the straight line that mathematically is the best fit to that set of points.
Because you draw the line in between the points.
Well, it's pretty complicated. The actual math to come up with that least fit line involves taking, if you take the distance between the dot and the line and square it and sum all of those up, it's the smallest number. In other words, depending on how this line is drawn, if I were to draw this line slightly different, it would be a larger total for the sum of those squares. In other words, where it puts this line is based on minimizing the distance from the red dot to the line.
Okay.
Okay?
Well, how come you didn't put 98? How come you put 8 over there and not like 1998? Just because?
Well, if we look at the problem, it says, let M be the standard mileage rate at T years since 1990. Well, if my horizontal axis is T, then I don't want to put 1998. I want to make it the number of years since 1990. So 1998 was 8 years since 1990. So I started my horizontal axis at 8. Okay, and went to 13. This is the number of years since 1990.
Okay.
And then that is M. And
right.
What I'm trying to say is that for any given set of points, for any given scatter plot, it's going to only come up with precisely one line that is the least squares best fit.
Okay.
And I did this on Wolfram Alpha. I also did it on my TI Inspire CX. And I got the exact same equation of the line. And that is this equation right there. 1.22.
How did you do that on your
I'm sorry, what?
How did you do that on your calculator?
Well, it depends on what calculator you have. What do you have?
A T3.
You have a TI-83?
Uh-huh.
Well,
yeah.
I don't have that, so I'm not sure I can actually show you how to do it. I had a TI-84 that's no longer working, and I remember how to do it on that.
So they're different.
They are. Every calculator is going to be different. I figured the easiest thing to do with you would be to do it on Wolfram Alpha. In other words, you could do it on Wolfram Alpha also, at least as long as you're around a computer. Now, if you're taking a test in class and you have to do it on your calculator, then you want to learn how to do it on your calculator for sure.
Right, I have to do it on my calculator during the test.
Okay, let me give you a way to figure that out. If you go to YouTube and type either scatter plot on a TI-83 or linear regression on a TI-83, you will be given a number of videos that are like 5 minutes long that will show you exactly how to do it. Okay? And that's really the best information I can give you. I looked up how to do it on my calculator, which was a TI Inspire, and it gave me this little 8-minute video here, and it works me through exactly how to do it on my calculator. But my calculator is significantly different than the TI-83 or 84, and so I don't feel comfortable giving you instructions on that. I don't have one in front of me. I'm not exactly positive how to do it. I can explain it partially. You have to make a list. List 1 and list 2. List 1 would be your X variable, or in this case, the time, 8 through 13. List 2 would be your Y variable, which is the M. In other words, the standard mileage. Once you get that input into your lists on a TI-83, you then have to hit the VARS key, V-A-R-S, and request a linear regression. And that's about as much as I know for sure to tell you.
So that should, so what about the next part?
The next part of the question?
Yeah, it says find an equation for the linear regression line using the
Okay,
calculator.
notice that my Wolfram alpha gave me that equation right here. And your calculator will also give you that. Okay?
Okay.
And it'll give you the exact same equation that I got, because when you apply the algorithm that the calculator uses, it's always going to come up with precisely the same straight line for those given points.
If it says round values to 3 decimal places, would it be 122.9?
Yes. And 21.833.
Okay.
That's the slope, 1.229. And the y-intercept is 21.83.
Oh, this is crazy. Draw a regression line in a scattergram by hand and on the calculator. Show your calculator results to an instructor. Wouldn't that just be what we just did?
Well, part C is going to look exactly like this. In other words, if you were to draw it by hand, go ahead and make a chart and enter your values for year 8, year 9, year 10, and so forth. And then, what does it say? And then draw the regression line and scattergram by hand. Well, you can't really draw the regression line by hand because you don't know what it is. Unless it's given you the equation, and then you could draw it. But primarily, you're going to be asked to draw a line that is the least fit, best line through that data.
The least fit best line.
I mean, the least squares best fit is what technically it's called. The least squares, and that basically means that the distance from the line to the red dots, square that, add them all up, and that's the smallest number they could find.
So draw the regression line and scattergram by hand and on the calculator. Show your calculator results to an instructor. Yeah, no idea what that means.
Well,
I mean,
that means when I did it on my calculator, here, let me see, yeah, I'm going to hold this up just for a moment, and I'm going to turn my camera on. Here's my calculator. Not sure how much of that you can see.
There you go.
Okay. Notice that that's exactly what we're looking at on the screen.
Right.
The same scatter diagram and the same line. And the same equation. It gives you the exact same equation, this equation 1.22 plus 21.83. So that's what you would get on your calculator, is this picture right here. And that's
a regression line?
a linear regression. You can actually draw regression lines of any kind of sort. In other words, you could draw exponential regression lines. Let's say I had a bunch of dots that looked kind of like that, and I thought that it was an exponential growth, and so if I asked the calculator to put a line in there that fits an exponential regression, it would look something like that. In our case, we're told that the linear regression is what we want. So we got a dot there, a dot there, a dot there, a dot there, a dot there. If you had to put a straight line in there, well, where would you start? You wouldn't necessarily start at that dot. It's going to look something like that. But it could look like this. Well, how do I know? I don't when I'm doing it manually. But if I have a calculator that has the algorithm in there, it's going to be able to do all of that tough calculation and tell me which line is the least squares fit. And that's what linear regression typically means. is which line represents the least squares fit.
So there isn't an option on your, so I guess I get so confused, kind of confused. Like A says make a scattergram of the data by hand and on your calculator. So the scattergram is not and does not include a regression line?
That's right. The scattergram would just be the red dots without the line.
So the regression line, the line is the regression line. So
yes.
Okay.
And it needs those red dots. In other words, what the calculator's doing is trying to come up with the best straight line that it can fit through those red dots.
So what's on your screen right now is a scattergram and a regression line.
Yes. And the equation right there. That's everything that this problem asks for. In other words, part A is make the scattergram. B, find an equation for the linear regression using your calculator. Well, that's also this equation, and it's the same one that my calculator gave me. And then C is draw the regression line and scattergram by hand and on the calculator. Okay, well, we could do it by hand. I did it by hand there. And on the calculator, it comes out that way.
Okay, and then, so essentially I can do it on my calculator and then just copy it on a piece of paper, correct? Isn't that the same exact thing?
Well, yeah, or you could do it on your piece of paper first. In other words, if I was doing it on a piece of paper, that would be 1 year after 1990. That would be 2 years after 1990, and so forth. Although in our case, it's 8,
9,
and 9, and 10. And you could start it like that.
Okay.
And then plot the M values. This is the mileage on that axis there.
Right, the mileage is Y.
So one can do the scattergram perfectly accurate on a piece of paper. What you would have a hard time doing would be the best line, because you don't know where that is. The calculator is needed to come up with this line. I mean, you could approximate it. Notice that I drew a line through my scattergram here.
Right.
And that's all you're going to do is look at your scattergram and draw the line that looks like it's the best fit line for that set of points. But the calculator does it perfectly and gives you the exact equation, which is that.
Okay, so now I've been stuck on this. That wasn't the problem I've been stuck on this whole time. This is the problem. I have it right here. I took a picture of it. Did you want me to email it to you, or do you want me to?
Yeah, why don't you do that? If you have it in your camera, send it to davidcowan1949@gmail.com.
David Cowan 1949. COWAN?
Correct.
1949 at Gmail?
Uh-huh.
Okay, so this is my homework online, and it has multiple questions per question, multiple parts,
Okay.
and it is driving me nuts.
Well,
The problem is, like, I understand half of it, and then I don't understand the other half, and so it makes it really hard for me to figure this out. Okay, I sent one. I sent the first part.
Okay.
As you can see, I got them wrong. The second part, I didn't send the third part yet because I thought I would.
Okay, let's take a look at the first part here. I got it.
Oh, hold on 1 second. So we're going to window. You're not permitted to have homework open in 2 windows. What are you talking about? So basement is flooded. Okay. So basement is flooded. no idea where to start with this. No idea at all. Ft equals y is all I know. Right?
Right. And find a linear equation of f. Is that your answer or is that the proper answer?
Oh, that was the proper answer.
Yeah, you'll notice that
I'm
we
sorry,
go-
it gave me another question.
Yeah, let's talk about this problem.
Can I hold on one second. It gave me a different, it says a basement is flooded with 650 cubic feet over water and it takes 5 hours. So it gave me a different question.
All right, that's all right. 650 cubic
In
feet.
5 hours. Uh-huh.
And it empties in 5 hours.
Mm-hmm.
So that's going to tell us the equation. Notice that in this problem you sent me, if I divide 760 by 4, I get 190. That's the slope. In other words, it emptied 760 cubic feet in 4 hours, which means it emptied 190 feet per hour. Well, in your problem, it's emptying, let's see, 5 goes into 650, 130 cubic feet per hour. Right?
Plus 650? That's what I don't understand.
No, the equation that's going to represent this, f of t, is going to be the slope, which is minus 130, times t, the number of hours we're at, plus, that's the y-intercept, and in this problem it's 650. In other words, let's graph this. 5 hours, 650 cubic feet. So the water starts up here at 650. At the end of 5 hours, it's 0. So that's the line that represents this model. And the equation of this line is, well, y equals mx plus b is the equation in slope-intercept format. M is the slope. Well, we go the rise over the run. The rise is 650. The run is 5. That gives us a slope of 130. Going down, it's negative 130.
Going down is negative 130?
In other words, the slope of that line is negative. It's not positive. Positive slopes look like this. Negative slopes go from upper left to lower right.
Sometimes I wonder about myself. This is all I need. So what's the domain of the function? Explain, it says.
Well,
So
the domain is the allowable values for t. Well, in your problem, it's 5, 4, 3, 2, 1, and 0. So the domain would be 1 to 5.
Not 0?
Excuse me, 0 to 5.
So
Yeah, because it doesn't empty the basement. It doesn't clean out the basement until time 5 hours. And at time 0 hour, it's got 650 cubic feet of water in it.
So all numbers between 0 and 5, essentially, right?
Yes.
Let's see if I can type all this in and see how it works out. So 0, all numbers between, is it x? I don't understand this stuff sometimes. How come, you see those little bird mouths? So it says 0, every number larger than 0, t, is that what it means? And any number smaller than 4?
Yeah. Repeat that, only make it go 0 to 5.
So sorry, oh, maybe because I forgot to put t in. No, I put x. Okay, so that's good. So now it says choose the correct answer below. Time is the output. The pumping, so I sent you another frame, I think.
Okay.
Did I? Time is the output. The pumping took 5 hours starting from 0.
Yes, you did. Okay. So where are we at? We on A? Time is the
Wrong.
output. The pumping
Yeah.
took, in your case, 5 hours. Thus, the domain is the set of all numbers between 0 and 5 inclusive.
Between 0 and 5. So B says the same thing, starting from 0. Thus, the domain is a set of all numbers between 0 and 5 inclusive. Is it not the same thing? Oh, mine is the same thing. So what's the difference between A and C there on your screen?
Well, in A, it says time is the output.
Oh, time is the input.
C, it says time is the input. The pumping took 4 hours starting from 0. Thus, the domain is the set of all numbers from 0 to 4, inclusive. Oh, I see. You're supposed to choose the correct answer.
Yeah.
Time is the input. Time is the independent variable.
That's right. Time is input.
So,
okay, so time is the input.
C would be the right answer. If you have a choice between time is the output and time is the input, choose the time is the input. And
Okay, I have two options though. That time is the input.
Okay.
So time is the
go
input.
from 0 to 5 inclusive.
5 starting from 0, So it says time is the input. The pump took 5 hours starting from 0. Thus, the domain is a set of all numbers smaller than 0 and greater than 5. Oh, no, it's
That's not it. Yeah, that's smaller than 0 and greater than 5. We want from between 0 and 5 inclusive.
So now it says what is the range of the functions? The range...
Okay, the range is going to be the y values. Okay.
Okay.
So if we look at this particular, let's see, I still don't have yours, but we know that the y values goes from 650 to 0, right? It's never above 650 and never below 0. So the range is what that is, from 0 to 650 inclusive.
So how do I write that? 0 to 6, so 0 the bird beak to 650 inclusive?
Let's see, are you trying to type it into this box right here?
Uh-huh.
And what variable are you using? F of t?
Oh, I think just t.
No, t is the input. T has to do with the domain. It's the amount of water.
Oh, the range.
That has to do with the range. And that is F of t. Notice it says let F of t be the number of cubic feet of water. So for the range, F of t would be greater than or equal to 0, less than or equal to 650.
F of t is greater than or equal to 0. I don't have an option to write that on there. Can you show me on the paper like what it would look like?
Yeah.
F of t, I can't show you on mine, sorry.
I can. Yeah, these computerized tests are brutal because you have to put them in exactly the way they...
Oh, yeah, it's horrible. So I have that.
Greater than or equal to 0 and less than or equal to 650.
Oh, yes. Okay, so I did almost have it right, but not exactly. Greater than or less than. Hopefully this works. If I ever have a space in there or anything, it always says sorry.
I know. I've struggled with these tests for 2 years now. They are very demoralizing for students. And,
yeah, they're really horrible.
Tutors, because it's so easy to make a mistake and they're just so unforgiving.
Yeah, I just don't understand it. So now it says, last part, choose the correct answer below. The amount of water pumped is the output, right, or is the input? That's the first part of it.
The output.
The amount of water pumped out is the output, right?
Uh-huh.
So since the volume of water is 650 cubic feet, and the pumping lasted until all the water was pumped, the range is a set of all numbers greater than 650 inclusive? It's not. It's in between 0 and 650.
Greater than 0 and less than 650.
Why is this so hard for me sometimes? I don't get it. Yay, I got that one done.
Okay.
That,
Notice
now,
also this question where it says choose the graph.
yeah.
Well, it's this graph over here.
I knew what it was. I didn't take my time. That was like the
It
7th time. I knew.
it started at 7:60 and went to 0 in 4 hours. Well, this one doesn't do that. That one doesn't do that. And that one increases. So
Right.
we need a curve that's gradually declining,
Mm-hmm.
a negative slope, and that would be this one right here.
Okay, hold on one second. This one, Parsons, math, I think, I don't know. Oh, it just keeps on kicking me out, which is making me so angry with this darn thing. What to call all the time? Okay, hold on, I'm getting there. So now, on to newer, bigger, worse problems in my life. Once I get there. Properties of exponents is the next section.
You can probably describe these to me. I don't think you need to send anything to me.
Okay, so let me see.
If you can verbalize the problem, we can do it.
4.1. Okay. Oh.
In other words, properties of exponents means if I have x to the third times x to the fourth, what's that equal to?
I don't know, but I know. Yeah.
Add the exponents. If multiplication is taking place, then you add the exponents. If division is taking place, then you subtract the exponents. If exponentiation is taking place, then you multiply the exponents. Those are your 3 basic rules for dealing with exponents where the base is the same.
Okay.
Okay?
Well,
and the way I teach people to memorize this is that when you do multiplication, you add. That's one level less than multiplication. When you do division, you subtract, which is one level less than division. And when you do double exponentiation, you multiply, which is one level less than exponentiation. So you always do one level less. And that's one way to memorize these 3 rules.
So it says 7 to the negative second power.
Okay?
I would assume.
If I had 7 to the negative 2 multiplied by 7 to the third, add the exponents, you get 7. Because it was 7 to the 1.
Whoa. You get 7? How did you do? How did
add negative 2
and
3, and you get 1. So I can write in a 1 if you like.
Well, so, I mean, is that the answer to 7? What?
Yeah.
Huh?
Yeah.
Where'd you get 7.3 at?
Oh, I just made up a problem. If I had, I'm not looking at your sheet.
No, well, it's 7. It says simplify the following expression using positive exponents only, and it says 7 to the negative second power. Just like that. It says
just
equals
like that?
what?
Oh, okay. Negative exponents merely mean reciprocal.
Oh.
So that's what that means. Negative exponents don't have anything to do with negative numbers. That's the biggest mistake students make, is they think it means a negative number, and it does not. Notice that this is equal to 1/49, a positive number.
It's a reciprocal, though.
Reciprocal, that's all it is. So if I had 7 to the negative 3, that's equal to 1 over 7 to the third.
How in the world?
So any negative exponent can be written with positive exponents by just writing the reciprocal. And vice versa. If I had 1 over 7 to the minus 3, then I can take that and put it on the other side of the fraction bar by changing the sign on the 3. That's equal to 7 to the third.
Well, it says the answer is wrong. It says the answer was 1 over 49.
Well, okay, we
Oh,
didn't simplify it. I didn't know that they wanted you to simplify it. I did say
sorry.
over 49, but
That's okay. That's okay.
okay.
I can punch it in. So if it's 4 with this negative 2, it would just be 16, so 1 over 16.
Uh-huh.
This is silly. Fantastic. They're going to get a lot harder here in a second.
That's okay. They don't really get harder as long as you remember those 3 rules. No matter how hard you give me, it's real easy with those 3 rules.
Can you remind me what the 3 rules were again so I can write them down?
When you're multiplying, you add the exponents.
Okay.
When you're dividing, you subtract the exponents. When you are exponentiating, you multiply the exponents.
Multiply. You don't multiply the end. Okay.
Yeah, so
Well,
if I said 2 cubed to the 4th power, that's exponentiation. I'm going to multiply those exponents. So that's going to be the same as 2 to the 12th power.
Okay.
Okay?
So this one says, in parentheses, negative 6 to the 0 power. I want to say 0, just because anything by 0, but.
Anything to the 0 power is 1.
So it says negative 6, and then it has 0 outside of the parentheses.
Yep, that's 1.
How come?
Any number to the 0 power is 1. And I mean any number including 0. If you take a million to the 0th power, it's equal to 1. If you take minus a billion to the 0th power, it's equal to 1. If you take 0 to the 0th power, it's equal to 1.
Okay. Perfect. So now, oh darn it, I messed up. 0. Oh, is equal to 1, huh?
Right. Uh-huh.
So negative 9 with to the 2nd power.
Like that?
Just no parentheses.
Well, it matters. Because if I have a parentheses, then I'm taking minus 9 times minus 9, which is positive 81. If there is no parentheses, then the 2 does not operate on the negative sign, and it's basically the same as writing minus 9 squared. Well, that's minus 81. 9 squared is 81, and the negative sign carries forth. So it matters a lot whether there's parentheses around that or not. If there's no parentheses, then the exponent only applies to the thing that it's next to.
Okay, and if there are parentheses?
Well, then it would be minus 9 times minus 9, which is positive 81.
Okay. I'm glad I have this on record. Here. Oh, Jesus.
I'm recording it also, and I will send you a copy of this file.
That's what I meant.
Yeah, you'll be able to see all of this again if you need to.
Okay, so here's one that I'm going to be like, what? So it says 14, and then it has 350, at the top, to the 350th power. And then it says 14.
Times?
No, it just has 14. And then negative 350.
It means times.
So simplify without using a calculator.
Okay, add the exponents, what do you get?
0.
So 14 to the 0th power is what?
1. Dang, that one. So you add the exponents, 350.
Only if you have the same base. In other words, our base here was 14.
Right.
So as long as you have the same base, these rules of exponents apply. If it's a different base, you can't do that. In other words, if I have x to the 3rd times y to the 4th, can't simplify that. That is not xy to the 7th.
You couldn't simplify it literally? Like there's just
That's as simple as I can get it.
Okay.
Okay? So the only way you can simplify it is if your base is the same. In other words, if I had x to the third times x to the fourth, that is x to the seventh. Or if I had numbers, let's take numbers. If I have 2 to the third times 2 to the fourth, that's 2 to the seventh, and you can test that, because that's 8 times 16, that's equal to 2 to the seventh, which is 128. Okay? However, if I had 2 to the third times 3 to the fourth, I can't do anything with that. I mean, that's 8 times 81, but I can't simplify it based on this. I can only simplify it by carrying out the operations. And, of course, if you have variables, you can't do that. So if you have variables, they have to be the same variable to be able to apply those rules of exponents.
Well, this one says simplify, so it's b to the third and b to -6.
Now, when you say b to the -6, if they're next to each other, that means they're multiplying. So it's really b to the third times b to the -6. Okay? Add the exponents. What do you get?
-3.
And then convert it to a positive exponent. What do you get?
b1 over b -3.
To the 3. It changes that exponent to positive when you put it in the reciprocal format.
Oh, I don't even know how I just got that. That's the
That
thing
right there is the key. That's what negative exponents mean.
-6, okay, b -3, and then when you change it to the reciprocal, right?
Makes it positive, right?
Makes the exponent positive. So that means 1 over b3. I have to figure out how to write this thing.
Probably 1 divided, maybe 1 divided by b raised to the 3 power. It depends on the program you have and as to how it allows you to input that stuff.
It's crazy. So in parentheses it says 3b to the 9th power. So all of that's in parentheses. Nope. 3b to the 9th power in parentheses. Or to the negative 9th power, sorry.
Okay, because I was going to say that's what that is. Okay.
So it's the same, that's the same as if they were all in parentheses?
No. In other words, if I had this,
That's what it is.
the -9 only applies to the b.
Okay, so that's
So that is equal to 3 over b to the 9th power.
okay, so 3b.
Whereas this, up top, the way I wrote it the first time, that would be 1 over 3b to the 9th power. And this 9 now applies to the 3, whereas it doesn't in that case.
So on the second one, on the lower one, it says 3b to the 9th power, all in parentheses, and then you converted, when it went across the reciprocal, it's positive.
Yeah, in
Right?
other words, is all I did was change this part to 1 over b to the 9th. So what I really had was 3 times 1 over b to the 9th, and that's equal to 3 over b to the 9th.
So if it were positive, you would have changed it to negative?
No, if it was positive, then it's simplified already. They've already got it with positive exponents, and you don't need to do anything to it.
So 3b, negative to the 9th power, all in parentheses, and then times negative 2b with negative 7th power.
Hold on a second. So we have 3b to the -9th. All times what?
Negative 2b to the negative 7th power.
Do the numbers first and the variable second. What's the numbers equal?
Negative 6.
What's the variable? B. What are we going to do with those exponents?
Well, I was going to go positive, 63, like
Well, we add the exponents, so it's negative 16.
Dang it. 9, 2b, negative 7. So these two we multiply.
Mm-hmm.
And then these two.
And now we're going to put that with positive exponents only, so I'm going to move the b to the denominator and leave the exponent there. So the answer would be minus 6 divided by b to the 16th.
Whoa. Negative b, negative 6b. All the exponents are always positive?
You have a choice. In other words, most tests want you to always give answers with positive exponents. So if I gave you a problem like x to the minus 2 over y to the minus 3, and they said simplify that using positive exponents only, well, the x to the minus 2 goes underneath like that, and this goes to the other side with a positive exponent. So if you have a negative exponent already in the denominator, just move it to the numerator with the positive exponent.
Huh. Okay. It's like, this is the type of stuff that's really easy for me, but like during a test, I just get so confused because there's so many things.
If you remember those 3 rules, you won't have any problems. Those 3 rules are critical.
Okay,
well. What is this? Tell me what this is.
I don't know.
We're doing,
write down the rules.
We're doing exponentiation. What's one level less than exponentiation? Multiplication. Multiplication. So we're going to multiply the exponents.
One level less than explanation was adding the first one?
When we were multiplying the base, in other words, if we had x to the 3 times x to the 5, that's multiplication going on there.
Mm-hmm.
So we're going to use addition with the exponents, which is one level below multiplication. Okay, if we're dividing, same base, different exponents, we're going to subtract the exponents. And it doesn't matter whether one's positive and negative. If I made that a minus 3, let's say we have x to the 5th divided by x to the minus 3, still going to subtract the exponents. 5 minus a minus 3 is 8.
5 minus a minus. Oh, yeah. How come you didn't add them, though?
Because we're dividing.
And you have to multiply?
No, you add when you're multiplying, you subtract when you're dividing.
Subtract when dividing. Okay. So, negative 5b to the negative 7th c, let's keep going, c, to the 4th power, all of that in parentheses, and then all of this in parentheses, negative 3b to the 9th power, c, negative 4. I think I can take the c's off, right?
Well, yes, c to the 4th times c to the negative 4th. If we add the exponents, we get c to the 0. That turns into 1. And 1 is the same as doing that.
Right, okay. So then I can go, now because I'm multiplying, I add the exponents.
Do the numbers first, then do a variable, and then do another variable. In other words, do them one at a time. What's the minus 5 times minus 3?
15.
What's b to the minus 7th times b to the 9th? Add the exponents.
Negative 63. Oh, add them. Dang it, I knew that too. 16. Well, no, 2. Sorry.
That's all right. That's your answer. That's your answer. Now, had we come up with a negative 2, In other words, let's change the problem slightly and make it b to the 7th and b to the minus 9th, so that when we added them we came up with that. That's not an acceptable answer because it has a negative exponent. So you would have to change that into 15 times 1 over b squared, which is the same as 15 over b squared.
Okay, yeah, that makes sense. Okay.
All right.
So 2b to the 6th power, c to the 5th power, all in parentheses, to the 3rd power, then all this is in parentheses, 3b to the 3rd power, c to the 2nd power, and then all of that to the 2nd power.
Okay, these are all easy. They're easy because there's only 3 things we have to do. We have to either multiply, we have to either add, subtract, or multiply exponents. We just have to remember which rules is applying. Now, this 3 applies to everything in the parentheses. So I can distribute that immediately, and I could write this now as 2 to the 3rd, and then what is b to the 6th to the 3rd power going to be?
6 times 6 is 6
what is b to the 6th to the 3rd power? We're doing exponentiation there, so we want to multiply.
18.
Okay? And then what is c to the 5th to the 3rd power?
15.
Okay, so now we have that. Now let's distribute this exponent on the right. So that would be 3 squared. And what's the b term?
6.
Okay, and what's the c term?
4.
Okay, now we can do the multiplication. What are the numbers? This is 8, that's 9, 72.
Well, wait, where did you get that from?
Well, 2
oh, you're actually doing, okay.
8, 3 squared is 9.
Okay.
Okay, so that's 72. What about the b's? What exponent goes with the b's?
Well, do you just add them?
Yep.
No.
Yeah, we're multiplying. In other words, what we're doing is b to the 18th times b to the 6th.
So we're adding. Okay, that's right. So 24, b to the 24th, and then c to the 19th.
Uh-huh. And there's your final answer.
I know you probably think I'm crazy. Just, I don't know. It always helps so much to have someone. And they have, like, math tutors, but there's 500 people in there all the time. That just is too much.
Well, the future of tutoring is definitely online. I do about 90% of my tutoring now online, even though 100% of my students live within 15 miles of me.
Wow. Yeah. So now, let me just see if I can figure this out on my own. I don't think I can. So 3, I'll have you write out, maybe I'll try to do it, I don't know. 3b to the 5th, and then c to the negative 3rd, and then that all in parentheses to the 3rd, and then this is in parentheses is 2b to the negative 2nd, or squared, I guess, c to negative 2, and then that is negative 2.
Okay, so let's take care of this outside exponent first.
Okay.
Let's do it one step at a time. So let's do 3 cubed, b to the 5th cubed, and c to the minus 3rd cubed. So what's 3 cubed equal to?
3 times 3 is 9 times 3 is 27.
Okay. What's b to the 5th cubed?
15.
Okay. What's c to the minus 3 cubed?
Negative 9.
It's as simple as that. In other words, all we're doing is multiplication, addition, or subtraction. What's 2 to the minus 2? For the moment, we'll write it like that.
Okay, and then b to the
b
4.
Minus 2 to the minus 2, that becomes b to the positive 4.
Yeah, and c 4.
C to the positive 4. Okay, the numbers are going to be 27 divided by 2 squared, which is 4. So that's the number part. In other words, this is 1/4.
Wait, where, what? Why, how come, why didn't we start, wait, what?
2 to the minus 2 equals 1/4. So I did the numbers first. This was a minus 2. And
How can we just say it was 4? Right, okay, I see what you're saying.
But the 4 goes in the denominator, not the numerator. And that's how I got this.
How come when we didn't, when we just, when we did the writing it out or breaking it, simplifying it, how come we did 2 to the negative 2 and we didn't just say it was -4?
Well, I should have said it's not -4. It's 1/4. Remember, negative exponents don't mean negative numbers. Look at down here. 2 to the minus 2 is the same as 1 over 2 to the 2.
Well, okay.
Oh, let's go down here. 2 to the minus 2 means 1 over 2 squared. That's what it means.
Okay, yeah.
So that's 1/4.
Okay.
Okay. Now when I combine the numbers, 27 times 1/4 is 27 over 4.
Okay, right.
Okay. So that takes care of the numbers. Now let's look at the b's. What is b to the 15th times b to the 4th?
Oh, b to the 19th.
Okay. What is c to the minus 9 times c to the 4th?
Well, I'm assuming because it's c.
Add the exponents.
Right, it's c to -5, but how come it's not some crazy -1/4 or something?
That's all you do. Because we have the same base, we're going to add the exponents. That's just the rule. Now, this isn't a good answer because it has negative exponents. So I have to convert that to where c has a positive exponent. And the way I do that is by putting it in the denominator. In other words, c to the minus 5th equals 1 over c to the 5th.
Wow. So it's 27 over 4, b19, c over 1/5.
27, b19. I'm going to put the 4 in the denominator, and I'm going to put the c in the denominator, like that. And that's your answer.
Oh, jeez. I'm all, this is 27, b19. I always, man, this is, I took algebra 75 years ago, and I'm like,
I know.
Wow.
It's just something you're going to have to relearn, just like I did. I mean, you can see by my picture, it's been a long time since I graduated from college, and I've been tutoring for 6 years, but I pretty much had to relearn math completely from scratch.
Oh, yeah. So this one's a little, well, this one's, says x to the -9th over x to the 8th. So I'm assuming I subtract because I'm dividing, right? So just...
Correct. So first of all, do the subtraction.
Yeah, x, I mean...
What's minus 9 minus 8?
Wait, why minus 9 minus 8?
Well, because you're always subtracting that minus that. So it's minus 9 minus 8, which is minus 17.
Whoa.
So my answer is x to the minus 17th, which is 1 over x to the positive 17th.
Because you can't have a negative in that.
Exactly. Any negative exponents you need to change so that they're positive exponents. Now notice that I could do this problem a little differently if I wanted. I can immediately put the x to the 9th, I could say that's the same as that, times 1 over x to the 8th. Well, now I'm going to add the exponents, so I'm going to get 1 over x to the 17th. I get the same answer do it the other way. But I would advise always starting out just using your rules of exponents. In other words, immediately that minus that. Then if you end up with a negative exponent, you can change it to a positive easy enough. But there's no need to change everything to positive exponents in the middle of the problem. Just work through the problem to get a final answer and then change all your negative exponents to positive where needed.
Okay. Do you have time for a little bit longer?
You know, I don't, because I have another session and I have something I have to do before then.
Okay.
I could do a few more minutes, but I couldn't do much more than that. Do you have another problem or two you want to do?
I do.
Okay, well, let's do them. We can do them quick.
This one is 15b, negative 6c, negative 5.
Hold on.
I'm sorry, 16b to the negative 6th power, and then c to the negative 5th power, and d9 over negative, negative 45c to the 3rd, b to the negative 5th, and d to 9.
Okay. Well, let's start from the beginning, even though we can see that that d to the 9th and that d to the 9th cancel.
Okay.
But let's start with the number. What's 15 divided by minus 45?
Sorry, it's...
Negative 1/3.
Right, negative 1/3.
Okay. So that's this part. Now what is b to the negative 6 over b to the negative 5?
Negative 11?
No. It's minus 6 minus a minus 5. In other words, you have to subtract the exponent. So I have to do minus 6 minus the minus 5.
That's 1.
Minus 1. Minus 6 plus 5 is minus 1. So if I'm going to write out the b in the numerator, it's going to have a minus 1 like that.
And then c is minus 5 minus 3, which is negative 8.
Uh-huh. And d is 9 minus 9, which is 0, so it's d to the 0, which is 1. Okay. Now, that's my answer, but it's got all these negative exponents in it. So how do I write that with positive exponents?
You take them and reciprocate them.
So it's minus 1/3. What's b to the minus 1? 1 over b to the 1. C to the minus 8 is 1 over c to the 8.
1 over c to the 8. Oh, yeah, okay.
So my final answer is minus 1 over 3bc to the 8.
But would it still be correct if you would just kept it the one prior to that, or no, because you didn't simplify it?
You mean this answer?
The one next to
Ah,
it.
the one next to it. Yeah, that's the same as this.
Okay. Okay.
In other words, this means they're all being multiplied together, and that's what this means also.
Okay. 3bc. 3bc to the 8th. It says use equivalent properties for exponents bm over bn equals bm minus n.
Yeah, b to the m over b to the n. I'm going to subtract the exponents. That's one of those properties.
3bc 8. Oh, negative. That's why. Dumb. Darn it. Oh, yeah, no, it didn't give me that. 1 over negative 3bc8 is what we had, I thought. Oh, it's not negative 3, it's negative 1.
Well,
this is
it's also negative 3. In other words, that's the same thing as this.
Yeah, it wants the negative sign in front of the whole equation.
Okay, and that's the same as this.
Right. I don't understand why it doesn't let me.
Well, I don't under. That's the bad stuff about computerized testing, is that there's no person there that recognizes that these are all three the same thing. In other words, that is the same as that is the same as that.
Right. Okay. Well, I guess I will let you go.
Okay.
And then, you PayPal, I'm assuming? Is that what it was?
Well, Ryan paid me $40 yesterday, and that actually squares us up. My online fee is $36 an hour, and he and I probably went just long enough last night for $4 is fine. My first half hour was free, so his 40 gets me square through this session today if he's paying for you.
He is.
And does he still want this Saturday session at 10 or 11? Do you know?
I'm sure he does. We're going to keep it there.
Okay, I'll leave it on the schedule then. And
an hour?
It's an hour, correct? Do you want me to call you or call him?
I will email you with that information in just a minute.
Okay.
Thank you.
You're welcome. What's your email address, Charlotte? And I will send you, as soon as this file gets processed, I'll send you a copy of it. And it'll give you a chance to review this session if you want.
Charlotte.cl@hotmail.
Charlotte.cl?
T like Tom, H-I-E-L.
Oh, at Hotmail? .com? Okay. It'll probably be, might not be till tomorrow because I've got a pretty busy day and my computer can't process these things while I'm doing sessions. So
okay. Well, thank you.
Process tonight, but I'll get it to you by tomorrow.
Okay.
You'll be able to view it. It's like in a YouTube file. So.
Yeah, I should be able to view it, whatever file it's in. So.
Yeah. All right. Well, it was nice working with you, and we'll probably talk again.
All right. Thank you.
You're welcome. Bye-bye. To close out a GoToMeeting, just click on the X in the upper right-hand corner, and that'll